Okay, so we've got a couple of force diagrams here. We're given the accelerations of each of these, and in both questions we're going to be aiming to try and find x and y from that information. Okay, so if we start on question A, first thing we can do, if we resolve vertically, because we're going to resolve vertically and we're going to resolve horizontally as separate things. Resolving vertically, we've got two forces, y and 2g. The acceleration is horizontal, so there's zero vertical acceleration. That means the resultant force must also be zero. So therefore, y subtract 2g is equal to 0. Therefore, y is equal to 2g. So that's 19.6 newtons when we take g to be 9.8 meters per second squared. Now, if we resolve horizontally, the horizontal forces are x in the direction of the acceleration, so that's positive. 4 newtons is against that, so it's negative. And rather than equaling 0, it equals ma. So Newton's law is F equals ma. Let's put that in there. So the mass is 2, the acceleration is also 2. So x take 4 is equal to 2 times 2. Solve that, we get x equals 8 newtons. And the second example is pretty similar to that. So again, if we resolve vertically, we'll see we've got y going upwards, and then the 20 and the 4g are both going down, so they're both negative. And again, the acceleration is horizontal, zero vertical acceleration, so the vertical component of the force must also be 0. So y take 20 take 4g is equal to 0. We just need to then solve that to find that y is 59.2 newtons. And then resolving horizontally, as we did in the previous question, using F equals ma, x take 80. Actually, we're going to do it the other way around because it's going this way, accelerating this way. So we'll take that as the positive one. So 80 take x is equal to the mass, which is 4, times the acceleration, which is 2. And then we can just solve them there to find that x would need to be equal 72 newtons.